Good evening, everyone. My name is Omane Abu, and I work for the City of Glendale Water Services Department. Joining me tonight is Joanne Toms, who also works for the City of Glendale Water Services Department, and Doug Donahue, our guest presenter with Ewing Irrigation. I'd like to welcome everyone to tonight's class on programming your irrigation controller. But before diving in, let's go over some webinar logistics. So attendees are all muted and the class will be recorded. The recording will be available on the city's water conservation website and YouTube channel in about a week. You can type your questions and comments in the Q&A or chat functions, and Joanne and I will read and respond to as many as we can throughout the webinar. The class is scheduled to be about an hour and a half long. We have 1 hour allotted for the presentation and about 30 minutes for questions. We'll aim to stay on track as we want to be respectful of your time. If you experience any significant technical difficulties, please contact Joanne Toms via email or phone. Her email is jtoms, T-O-M-S, @glendaleaz.com, or you can call her at 623-930-3596. After this presentation, we will follow up with an email that includes a copy of the PowerPoint, resources, recording, and a link to the survey. If you complete the survey, you'll be entered to win a free gift card from a local nursery. Let's just go over some Zoom attendee features. We want to make sure that you're all comfortable here as we're going to have a great class tonight, but we want to make sure that you feel comfortable with using some of the features. So this is what your current view might resemble. You can play around with the features so you're comfortable. You can click and drag the vertical bar located in between the presenter and the presentation to enlarge or shrink the presentation view. You can also adjust the audio settings in the bottom left-hand corner of your screen. And feel free to send any comments using the chat button or share your questions using the Q&A button. Joanne and I will do our best to answer questions during the presentation as they come in, but we should have enough time for Doug to answer questions at the end of his presentation. I would like to highlight a few free publications. The first is a free guide called Landscape Watering by the Numbers, which walks you through how much and how often to water, how to set your irrigation timer, and how to troubleshoot your system. And I know Doug will be referring to this guide for tonight's presentation. Another is the Smart Home Water Guide. This publication takes you step by step on how to discover typical leaks and reduce water use in and outside your home, and is available in English and Spanish. You can access these guides online using the links on the slide, or Glendale residents can request to have a hard copy mailed. If you don't live in the city of Glendale, check with your local water provider and they might be able to mail out a copy for you. The next free resource I'd like to share is you can opt in to receive monthly watering reminders right to your phone. All you have to do is text when to water to 33222 to receive a text with a link to the month's watering guidelines on the first of the month. This is a great resource if you can be forgetful like me, and this tool is designed to ensure your plants get the right amount of water to thrive. And of course, this workshop wouldn't be possible without our friends at Ewing Irrigation, and I'm excited to introduce to you tonight our presenter. Doug Donahue is a 40-plus year veteran of the green industry, and most of that time spent in irrigation. Doug is an account manager at Ewing Irrigation, working with large commercial and residential landscape and maintenance contractors, as well as municipalities. He's a frequent teacher, speaker, and presenter. He enjoys giving back to the industry that he loves by presenting as he is tonight. Everyone, please welcome virtually Doug Donahue. Thank you so much, Doug, for joining us tonight.
Thank you, Omane. Let me get this fired up. Here we go. I've got it on my screen. Hopefully everybody else does, and hopefully everybody can hear me. Thank you for the introduction, Omane, and thank you, Omane and Joanne, for having me tonight. It's nice to see all of your smiling faces, at least virtually, and I hope that you'll get a lot out of the next hour and a half that we spend together as I share my passion for irrigation and specifically water management. So tonight's topic is irrigation controller programming. And we're going to take a look at a lot of different things as we go through the presentation. But what I want to start off with is when we talk about irrigation controller programming, is it doesn't have to be hard. Most of you have probably seen this video from a couple of years ago, and I thought it appropriate to make my point for when we talk about programming irrigation controllers, because as I said, it doesn't have to be hard and it doesn't have to drive you crazy. And if you'll forgive the maybe pun at this point, it doesn't have to make your head spin trying to figure out how to program an irrigation controller. Whoop. So let's see, why can't I change to the next slide? There we go. So the interesting thing about that video, I guess, is that lady didn't really even want to be rescued. I'm going to start off talking about some key irrigation terms, but before I do that, my presentation will be about an hour, and we've saved a lot of time for questions at the end of the presentation. And I want to say that I absolutely love your questions. I, of course, am going to convey some material to you this evening, and it may spawn some questions. If you can save those till the end of the presentation, we should have plenty of time to answer your questions. And answering your questions is what makes these presentations of value to me, because I really feel like I'm able to share what I've learned over the years and help you with issues that you might be facing. So I hope we have some good questions at the end of the presentation. So we're going to start off, as I said, by talking about some key irrigation terms that we'll be talking about this evening in the presentation. And so I kind of want to just get everybody on the same page with these couple of terms. The first one we'll be talking about tonight is GPM, or gallons per minute. Most of our sprinklers, whether they're spray heads or rotors, the output of those is the water that's actually coming out of those nozzles is expressed in terms of gallons per minute. And a sprinkler head has to have enough water and enough pressure to make it work right. So again, the sprinkler output is measured in terms of gallons per minute. When we talk about drip irrigation, the output of our drip irrigation devices is measured in gallons per hour, or GPH. The next term that I want to talk about is precipitation rate. And that speaks to how quickly does a sprinkler or a drip device distribute water in its given area. And we'll be talking more about precipitation rate later in the program. And the last term I want to talk about is ET, or evapotranspiration. And you've probably heard of evapotranspiration. ET, or evapotranspiration, is a measure of the water that is lost due to evaporation and used by the plant as it grows. It gives off water back into the atmosphere, and that's called transpiration. And we can actually measure the amount of water that's lost on a daily basis, either to evaporation or transpiration, and quantify that with a measurement. So we'll talk more about ET again as we go. So the topics we're going to cover tonight, we're going to look at what I call three broad categories of irrigation controllers. We're going to look at some irrigation controller programming basics, some things that are common to all irrigation controllers that you need to know. Then we'll take a little deeper dive into the science, and I like to use the word science because I think it's important that as we go through things tonight, you kind of understand the science behind what I'm talking about when we talk about programming your controller. So we'll be taking a deep dive there. Then we're going to look at what you can do to program your controller smarter. And we'll look at some smart controllers and how they get programmed differently than a regular irrigation controller. And we'll finish up with a special opportunity that will hopefully be of some interest to many of you on the presentation tonight. So when we talk about three broad categories of controllers, these are the ones that I'm going to address tonight. One would be basic irrigation controllers, like what most of you probably have at your residences. The second category that I want to look at is controllers that can be made smarter. And last but not least, we'll look at some what are called smart irrigation controllers, and we'll kind of define what a smart irrigation controller is for you and talk about how it irrigates differently than the basic irrigation controllers that we're going to start off talking about. So here we go. These are examples of basic irrigation controllers, and some of these hopefully look familiar to you as ones that you may have on your residences. You may have ones on your residences that look different than this. There are many, many, many different types of irrigation controllers. These are some of the major irrigation manufacturers. I've got a Irritrol, a Toro, a Rainbird, and a couple of Hunter controllers. Those are considered to be the four major irrigation manufacturers. But this controller here is by a company out of Utah called an Orbit controller. And I see many, many, many Orbit controllers on residences that I look at. It's a pretty popular residential controller. This controller here is called an Irritrol rain dial. And over the past probably as many as 40 or so years, this has been the most popular controller in the Phoenix metropolitan area. So I would venture to say that probably a lot of you have Irritrol rain dial controllers. It's an excellent controller. So again, these are just examples of what I would consider to be basic irrigation controllers that you're going to likely have on your residences. And again, you might have ones that are not pictured here on the screen. So we'll start talking now about some controller programming basics. And again, there are certain things that are common to all irrigation controllers. And so when we're going to start talking about programming an irrigation controller, there's a couple things that might seem silly to mention, but number one, the controller has to have power. Number two, and these are different than the numbers I have on the screen right now, these are bonuses. But the second thing that's going to be important for an irrigation controller to work is it has to have water turned on. So these are all going to be things that if you have a controller that's not watering, you can check. First thing is going to be, does it have power to it? Is the water turned on? And then we'll talk about the four things that I have on the screen here. And again, these are common things to all irrigation controllers. The first thing we have to do is we have to tell that irrigation controller what is the correct date and the correct time so that it knows how to water. And normally what you do when you start to program an irrigation controller, you see this dial in the middle here. This is called a hybrid controller. So it's easy to program. You're going to just start turning the dial around to the right. So this first dial position, although you can't read it, says set current date and time. And when you go to program your irrigation controller, normally in the display, whatever digit or position you have the opportunity to influence is either going to be flashing or it's going to have a line under it. And so that's the only thing that you can influence. And then typically you're going to have up and down buttons, and then these are going to be forward and backwards. So this display right now says 12 o'clock. If I wanted to change it and there was a line under the 12 or that digit was flashing, I could use these up and down arrows. Oops. Sorry, I did bad. Bear with me here a minute. You got a real touchy keyboard tonight, I guess. That's the worst that happens. We'll be fine, right? Okay, so if I wanted to try to influence that 12 digit, then I would use the up and the down arrows or the left and the right arrows to go over to the minutes. And once I do that, I'm going to push this button and it's going to take me to the date. And I'm going to have the day of the month, I'm going to have the month, and I'm going to have the year. So again, use your up and down arrows to change that so that you get your programming of the date and the time entered into the controller. Okay, the next three things are really important. If you program two of the three, your controller is not going to water. You have to program all three of these next things. And again, it's just a matter of turning the dial, continuing to turn the dial around to the right. The next thing that you're going to tell the controller is what days do you want the controller to water? And you have a lot of options on these controllers. You can pick days of the week. I want it to water Monday, Wednesday, Friday. You can pick the odd days or the even days, or you can pick what are called intervals. And an interval would say, I want to water every 10th day or every 14th day or every 17th day. So the manufacturers give you a lot of flexibility in terms of how you want to have the controller water. Next, turn the dial to the next dial position, and you're going to say what time or times do you want the controller to start. And again, you're still going to just use your same arrows and plus and minus keys up here to make any changes that you need to. And the reason why I said what times to start is, as you know, if you've lived in this area for any length of time, during this time of year, if we want to have green grass, we have to do what's called overseeding. And when we germinate that overseed, we have to have a lot of short irrigation cycles throughout the day to keep that seed moist until it germinates. And we're going to do that by having multiple start times on the controller. And so that we have the ability to keep that seed moist until it germinates. And then the last thing we're going to do with another dial position is we're going to tell the controller how long we want it to water on each station. So again, you have to have all of that information programmed into the controller, and it doesn't matter what kind of controller you have. All that information has to be programmed into the controller for you to be able to irrigate. Okay. Now, I want to talk about multiple program controllers, and I think this is typically a source of confusion. So hopefully the way I'm going to explain it will make sense to you. Most irrigation controllers these days have multiple programs. Okay, so you only have one controller hanging on the wall, but it's like you have three separate controllers. The programs are going to be called A, B, C, or they're going to be called 1, 2, 3. In some cases, you might have 4 programs or even more. But the way I like to think about it then is I like to think about the A program being its own controller. So again, you only have one controller, but when you use these programs, it's like you have an A controller, that's the A program. You have a B controller, that's the B program. And you have a C controller, and that's the C program. Well, why would you need all of those programs? Well, what those programs give us the ability to do is to water hydrozones independently. So what's a hydrozone? A hydrozone is a group of plant material that has a similar water requirement. So for example, you might have several valves or stations or zones on your property that water lawns, okay? So a lawn is a hydrozone. A lawn, although those valves are likely going to have similar water requirements. So all your lawns should be a hydrozone, and all your lawns could, for example, go on the A controller or the A program. And we might say, I want those lawns to water Monday, Wednesday, Friday at 8 a.m. for 10 minutes on each station. Okay, now we got the B controller or the B program. That's going to be maybe for our shrubs. And our shrubs have different water requirements than our lawns do. So our shrubs are going to be a separate hydrozone, meaning an area or a group of plant material that has a similar water requirement. So we're going to put all those valves or stations or zones on the B controller or the B program. And we might say we want that to water twice a week, every third day, for example, if we do the interval. And we want that to water at 2 o'clock in the morning for an hour. So you can see how we have the ability with these multiple programs to water these hydrozones based on their specific water requirements. And then we have the C controller or the C program. That could be for pots on the back porch. That could be for mature citrus trees or mature desert landscape trees that maybe only need to be watered every 28 days. And they need to be watered for 4 hours at a time. And we're going to do that at 8 o'clock at night, for example. So hopefully that helps you understand, if you have a controller that has multiple programs, what those different programs are used for. Okay, most of our presentation today is built around this landscape watering by the numbers. And one of the unfortunate things about us having to do this virtually versus doing it live is, if we were actually doing this live and I was standing up in front of the room doing the presentation right now, I would be handing you out each a hard copy of this, because we are actually going to be going through this publication during the presentation tonight. So it's unfortunate that you don't actually have one in your hands per se, but Joanne has made provision for you to access it online. And I certainly would recommend that you acquire a hard copy of this publication or print a copy of it off. It is available through the city of Glendale, as Omane said in the opening. This is an excellent resource, and it's what we're going to be using mostly tonight for the presentation, because it is very simple. It's a very simple publication in terms of helping you understand what goes into programming your irrigation controller, teaching you how to program your irrigation controller. And there are some wonderful pointers in here as far as water conservation tips and just little things that you can do to make your system that much more efficient. So make sure that after the presentation, you either get a copy of this from City of Glendale or print off a hard copy, as I've done, so that you have that as a resource. So I mentioned we want to kind of look at the process that this guide walks you through. And this is one of the early pages in the publication. And basically what it boils it down to is that there are 3 very easy steps that you need to follow. And the guide walks you through it to determine how your irrigation controller should be programmed. So where you see in the publication itself, numbers 1, 2, and 3, 1 says how much water your plants need. 2 says how much water each part of your watering system applies. And 3 says match your system's output to the plant's needs. And I've kind of translated that into language that I use in my profession that equates to those same 3 points. And we'll be referencing these 3 numbers as we go through the presentation. So know how much water your plants need. I call that the plant water requirement. Number 2 in the publication says know how much water each part of your watering system applies. I call that the precipitation rate. Again, precipitation rate speaks to how much water does a sprinkler head or a drip emitter put out in its area in a given time. And number 3 in the publication says match your system's output to your plant's needs. And I'm calling that then irrigation runtime, or how we're actually going to program the controller. So these are all pages right out of the publication. And this page is starting now to talk about how much water do your plants need. And I'll show you the chart in the upper right-hand corner on the next page. But what I want to point out on this particular page is this diagram in the bottom right-hand corner, which depicts emitter placement. And the number of emitters and the size of the emitters is going to be a function of, among other things, the plant material and the size of the plant material. But in particular, what I want you to notice is where the emitters are located. The emitters are located at the edge of the tree canopy and not right up against the trunk. So what happens a lot of times when new plants are put in, the emitters are located right at the base of the plant. But that's not the best way to water the plant material. As the plant material grows, we want to drive those roots out. We want to drive the roots out, and we want to drive the roots deep. So the way that we do that is to put the emitters at the edge of the canopy or the root zone. So wanted to call that to your attention. This is that slide or diagram that was in the upper right-hand corner on the last slide. And it says suggested watering depth for different types of plants. So basically they've got a small type plant, and they're saying you should water the roots 1 feet deep for that type of a plant. Then you have a little larger shrub, and it's saying for that little larger shrub, you should be watering to a depth of 2 feet. And then for your trees, to a depth of 3 feet. So keep that in mind as we go through this, because this is our plant water requirement, and it's one of the things that we're going to need to know to program our irrigation controller. This further talks then, based on the plant canopy, how much water, in other words, how many gallons of water is required to wet that root zone. So again, we're still talking about the plant water requirement. So over here on the left, it talks about trees, shrubs, and ground cover or cactus. Here is the diameter of that plant canopy. And then based on the diameter of that plant canopy, if we drop down and we see it's a tree, it tells us how many gallons of water that requires, 16 gallons. If it's a shrub with a 4-foot canopy, it requires 12 gallons. And if it's ground cover, it requires 5 gallons. Now, let me put a little asterisk by that, and let's talk about cacti for a minute. After cacti is established, it really doesn't need any supplemental irrigation. I see a lot of times where people have drip emitters at the base of a barrel cactus, for example. And that cactus ultimately winds up getting too much water and it dies. So be careful about how much water you're applying on your cacti. All right, this jumps now to part 2, where it says how much water does each part of your watering system apply. And my lingo for that is, again, precipitation rate. There's a ton of information just on this one page. But ultimately what it talks about is if you have a lawn, that a good way to figure out the precipitation rate or how much water is being applied by your sprinklers is to put out 6 or 8 little tuna cans, for example, or some kind of container. And they have you run your sprinklers for 15 minutes. And then you take a ruler and you measure in inches or parts of inches how much water is in each of those catch cans. And they actually, one of the last pages in the landscape watering by the numbers, they give you a little paper ruler that you can cut out and use. So you actually record, excuse me, that information. over here from each catch can, and then you average the number. So you have an average amount of parts of inches that your system is applying, and we'll be using that information later on. For drip emitters, they tell you that by counting the number of drips, that you can tell what size the emitter is. And we're going to talk about a couple of other ways that you can do both of these precipitation rate checks. But this is just a diagram of setting up the 6 or 8 little catch cans in the lawn area and running the sprinklers for 15 minutes. And here's where they're using the little ruler from the back of the Landscape Watering by the Numbers guide to measure in tenths of an inch how much water is in each of the cans. Again, what they're trying to determine is the precipitation rate of the sprinklers in that area. Now, that's one way that you can get the precipitation rate, and all of the information as far as programming your irrigation system in Landscape Watering by the Numbers is based on those measurements that you're taking from the catch can. What I want to show you, though, is out of the manufacturer's catalogs, whether it's a Rainbird catalog, a Toro, Irritroll, Hunter, or anybody's catalog that's in the irrigation business, is going to have performance charts for all their sprinkler equipment. And so one of the pieces of information that you can get out of the manufacturer's performance chart for a particular sprinkler head is the precipitation rate. So this happens to be a little Hunter 10-foot radius spray head nozzle. So it's telling you at 30 PSI, it sprays 11 feet. This is behind the arrow, how many gallons per minute it wants. And lo and behold, here is the precipitation rate of those sprinkler heads. Now, let's talk about that number real quick here. Precipitation rate of a typical sprinkler head nozzle is 1.5 inches per hour. For those of you that have lived in this area for any length of time and have been through our monsoon seasons, although they haven't been too bad the last couple of years, think about what it would look like out your window right now if it was raining at a rate of 1.5 inches per hour. You'd have a lot of flooding going on out there, and there'd be traffic accidents. People in Arizona don't know how to drive in the rain. But that's how fast a sprinkler head applies water, a traditional spray head, 1.5 inches per hour. And so there are some things that we have to do or take into consideration when we talk about how to program our irrigation controller. But again, in addition to the catch can information, you can get precipitation rate information from the manufacturer's catalog. So continuing on now, we're starting to talk about our irrigation run times, and the information on this particular chart here talks about if you have, I'm sorry, I've got a real touchy keypad. If you look at this chart right here, one of the things at the top, it says sprinkler run time, and on this axis, it talks about the tenths of an inch is average in your catch cans. And then across on the bottom, I can't read that, but what this is telling us is how many minutes we need to run our sprinklers based on the information that's on these two axes. Let me open this to that page so I can read that for you. Okay, across the bottom, it says sprinkler number output per 15 minutes. So these are all measurements that you've collected so far. And if you use those measurements, it's going to tell you then how many minutes, if you do a little cross section like this, it's going to tell you how many minutes you need to be running your sprinklers for. This is for a lawn. And again, there's a lot of other good tips over here and a lot of other charts that tell you how many minutes you need to be running in each month. So I hope you'll take advantage of my invitation and make sure you get a copy of this publication and take a look at it. Okay, so again, we're still on item number 3 here, where we're figuring out our irrigation run times to program the controller. And again, what we want to do now is we want to match the output of our system, in other words, the precipitation rate, to the plant's needs or the plant water requirement. And so this slide, which again is right out of the publication, says turf requires about 3/4 of water each time you irrigate. Your can test then will dictate how long that you actually need to do that running. Now, based on what we just talked about, if a spray head puts out 1.5 inches per hour, and this is telling me that I need to water for 3/4 of an inch, that would mean that your spray heads need to run for 30 minutes. And I want you to just kind of keep that information tucked away for a few minutes. We're going to kind of come back and talk about a 30-minute run time for spray heads. So again, if you look at this chart down here at the bottom, and again, we go back to your average can measurements in tenths of an inches. This is going to tell you how long you need to run your sprinklers to apply that 3/4 of an inch for your turf. So this is all about watering turf so far. And now we're going to talk a little bit about how to do either your drip irrigation or your bubblers. That's a little different because, again, we're doing things in terms of gallons per hour, and we're watering plant material that has a different plant water requirement than the turf does. So let's talk about emitters here. Again, same concept. We've got to match the output of our device, our irrigation device, to the plant's water requirement. So when I talk about emitters, this emitter right here is a very popular emitter. It's called a flag emitter. And this is a different kind of emitter that you might be seeing. And I want to talk about the differences. A flag emitter is not pressure compensating. And so what that means is you don't really ever, despite what it says on it, you don't really ever know how much it's putting out. If you have a really long run, the ones that are closer to the valve are going to put out more water than the ones at the end of the run because of the friction loss in the line. These, on the other hand, are called pressure compensating emitters. And what that means is anywhere between 10 and 70 PSI they put out, however much water it says they're going to put out. Okay. Now, most manufacturers color code their emitters. So, for example, this is a Rainbird Zerabug, and the red one is 2 gallons per hour. And with it being a pressure compensating emitter, it puts out 2 gallons per hour. And all the ones on the line put out 2 gallons per hour. You can't say that about these type of emitters. Now, in addition to being color coded, they will usually say on them somewhere that it is a 2 gallon per hour emitter. So if we were to go back to that slide where they were just having you count the little drops, you probably don't need to do that if you understand the color code of the emitter, or you can find on the emitter itself what it says its output is, especially with a pressure compensating emitter. And worst case scenario, if you don't know what it is, either take a picture of it and go to your irrigation distributor of choice and show it to the guys in there, or text the picture to them, and they'll help you know what kind of emitter and what size emitter it is. Same thing with bubblers. There are what are called flood bubblers or umbrella bubblers. We use these a lot for mature citrus trees and sometimes palm trees. There are what are called pressure compensating bubblers. So here again, you can get a bubbler that puts out 1 gallon a minute, 2 gallons a minute, 4 gallons a minute, or I think it's half, 1, 2, and 4 gallons a minute. And that's exactly what it puts out. And all of them on your system put out exactly the same amount of water. So when it comes to doing all these calculations, that you need for runtime. If you're using pressure compensating emitters and or pressure compensating bubblers, it's a lot easier to understand or know for sure how much water your system is putting out. Okay, this chart here is where you've now started to collect all of this information and you're going to start figuring out how long you need to run your control, your zones. So you've put what kind of plant it is and how big the canopy is, how many emitters, how big the emitters are, how many gallons are required to water the plant material that comes from the table down here at the bottom. You do the math and you come up with that zone needs to run for 6 hours. Okay, then here's some shrubs and some succulents. Problem is, in this example, they all have those on the same zone. Okay, these all have different water requirements. So how are you going to program station 1 on that controller when it says these plants need to water for 6 hours, these need to water for 4 hours, and these need to water for 2 hours? Ideally, those should be separate zones on the controller because they're separate hydrozones. But what the book talks about is if you make some tweaks to the emitters per plants, you can get these run times very close and you could actually have them on the same valve. It's not ideal, but if you have an existing landscape, you're not going to be able to go out and have all these separate hydrozones that I'm talking about. So you just have to manipulate either the number of emitters or the sizes of emitters, and you can get this to where you can have those on the same zone. Okay, so that's a quick look at landscape watering by the numbers and how you get the information, how you use the information, and how you would get the information then to actually input into your controller. So essentially now you've come up with what your run times are, and the question is, do the run times ever change? And according to the publication, the answer is no. You always want to water that plant to a depth of 1 foot or 2 foot or 3 foot. That's the idea. Now, what will need to change is the frequency. So this is a bell curve showing ET or weather information. Obviously, it's a lot hotter in the summer and the plant material is going to need to be watered more frequently, not longer, but more frequently. So if during this time of year, you're only running your system once a year, as it starts to get a little hotter, as it is pretty quick here, you might need to go to twice a year. And then in the peak part of the summer, you might need to be watering 3 or 4 times a year. So you don't change the duration, the water time, you change how frequently you're applying that water based on what the weather is doing. And this also, this little card comes right out of the publication as well. It's a handy guide to how frequently you should be running your irrigation system based on if you have trees or shrubs or ground cover or even turf grass. And they give you kind of a wide range. Like this says in the spring, you should be watering your desert adapted trees every 14 to 30 days. Well, is it 14 or is it 30? Well, you have to just use your head a little bit and be in tune with kind of what's going on with the weather when you have a basic irrigation controller. Now, I mentioned that there are a couple things that we can do to program our irrigation controllers smarter or smartly. One is we want to program those irrigation controllers as frequently as is possible. There are people who only program their controllers maybe once or twice a year, once for the warm season grass and once for the cool season grass. There are people who program their controllers seasonally, but the more frequently you can program your controllers so that they're watering based on the weather or the ET, the better. Monthly would be great. I'd be tickled silly with monthly. I don't expect anybody to go out there and program their controller weekly or daily or anything else like that. We want to make sure that you're taking advantage of those multiple programs that we talked about so that you're irrigating your hydro zones independently based on the water requirements of that similar plant material. And the last thing I wanted to talk about here is a thing called cycle and soak. And I want to come back to that one chart that said I should be applying 3/4 of an inch. And if I'm doing that with spray heads, that's a half hour. What happens is with our Arizona soils, with the caliche and the clay that we have in them, and if we have any kind of slope at all, and you run those spray heads for a half an hour as quickly as they're applying the water, you're going to waste a ton of water. You're going to have a lot of water that won't be able to go into the soil that quickly, so it just runs off, and it just is water you're paying for that's not doing you any good. So what we want to do is we still need to apply 3/4 of an inch of water. And those spray heads need to run for 30 minutes to do that. But we want to use a concept called cycle and soak. A lot of the fancy controllers have this built in as a feature. But based on the start times, those multiple start times that you have, you can say, okay, program A is my lawns, and station number 1 is a lawn station. So I want it to water 3/4 of an inch. So that means it's got to run for 30 minutes. But instead of running for 30 minutes straight, I'm going to divide it up into 3 10-minute cycles. So I'm going to set my run time at 10 minutes, but I'm going to have a start time at 2 o'clock in the morning and 4 o'clock in the morning and 6 o'clock in the morning, so that I give that water time to soak in. It more closely is going to match the water that's being applied by the sprinkler head with the soil's ability to accept that water. So cycle and soak, and you can probably do that concept with the types of controllers that you have. Okay, let's talk about smarter controllers, or controllers that can be made smarter. This is that little orbit controller that I talked about. You could take that orbit controller and you could put a wireless rain sensor on it. These are going to be retrofit devices that are going to make your existing controllers smarter. And so in the case of this wireless rain sensor, it's going to prevent your irrigation system from being on in the rain. That's one of my pet peeves, is driving around seeing sprinklers that are on in the rain, when you can put a little device on your controller like this that prevents your sprinklers from being on in the rain and saves you that money. Okay, what if I have a controller that looks like this? All right, here's a little soil moisture sensor. And by the way, that rain sensor will work on any manufacturer's controller. Same with this little soil moisture sensor. It will work on any manufacturer's controller. So you put this soil moisture sensor in your lawn, for example, and this device right here installs at the controller, and it tells you real time what the amount of moisture is in your soil. So that's saying in that display, it's got 27.6% moisture in the soil. And you might say, wow, the lawn looks really good. So if the lawn has 28% soil moisture in it, then I don't need the controller to water anymore. So the first thing the controller does when it's supposed to come on is it checks this device. And if the device says there's 29% in it, then it doesn't need to water. If it's less than 28%, then it goes ahead and waters and allows the controller to water. But again, little soil moisture sensor that works with any manufacturer's controller. Here's that rain dial that I talked about, that I said has been one of the most popular controllers in this area for forever. You can add a device called a wireless climate logic. And this device has some historical weather data built into it. When you put this into the controller, it just plugs into the existing controller that you have, and you program your zip code in there, and it unlocks some historical weather data for your zip code. And then you use this device here, which is a site-specific weather sensor that communicates with the receiver. And it's giving you real-time site-specific weather information on temperature and rainfall. So between the two of those, then it automatically adjusts the irrigation controller and tells it how to water. We're starting to water based on ET, starting to water based on weather information. Okay, what if I've got one of these controllers? This is a little higher end controller, but same thing. You can retrofit it with one of those wireless Irritrol Climate Logics. Here's a Hunter controller. What could I do to make this a smarter controller? They have a thing called a solar sync. And again, it has some historical weather data as part of the programming, and then some site-specific information on temperature and weather to alter the programming of the irrigation controller. This is all done automatically on a daily basis without you touching the controller. These are getting to be what we're calling smarter controllers. Here's a Rainbird controller. And Rainbird has the opportunity to put a little module in this thing called a Link Wi-Fi module, turns it into a smart controller where you get a lot of the features and benefits that you get with other smart controllers. And we're going to talk more about that pretty darn quick, like right now. So I've mentioned smart controllers. What is a smart controller, or what makes a controller a smart controller? A smart controller is a controller that's receiving some sort of sensor input, and it could be either a soil moisture sensor like I showed you, or a weather sensor like I showed you. And it's using that sensor input to reprogram the controller automatically on a daily basis, where we're watering based on the weather. And let's face it, these things are computers. So it says the controller scheduling engine determines how the water is applied based on the plant material, what type of irrigation device you have, what type of soil, what type of slope, and what type of exposure. So generally, when you have a smart controller, a true smart controller, for every station, you need to tell it what type of plant material am I irrigating, how am I irrigating that plant material, is it bubblers, drip, spray, rotor, what type of soil do I have, what type of slope, if any, what type of exposure, is it sunny all day? So in order for a computer to work well, you know that saying, garbage in, garbage out, we've got to program in as much good information into these smart controllers as we possibly can. And then it's going to take the input from the sensor as far as how much water is needed, and it's going to use this all these other variables we programmed in to determine how that water is applied. In other words, does it need to do cycle and soak? And if it does that for you automatically. So smart controllers water based on ET, evapotranspiration, and the precipitation rates of your irrigation equipment. So this is weather information out of the weather section from the Arizona Republic. And right here it says 0.62 inches is needed on your Bermuda grass if last watered, blah, blah, blah. So there's a way you know how to program your irrigation controllers right there. It's telling you the precipitation rate. Here's from University of Arizona Cooperative Extension Service for week ending so-and-so. It's telling you how much you should be watering if you want high quality turf or acceptable turf. So again, good information readily available on how to program your controllers based on weather. But again, a smart controller does that for you automatically. Smart controllers are using featuring the EPA WaterSense logo. And I thought I had this on this slide, so I apologize. But these manufacturers have to submit their products for testing by the Environmental Protection Agency. And if the smart controller can save 20% or does save 20% or more of the water, when the government tests it, then they get to use this EPA WaterSense logo. So if you're going to shop for a smart controller, you want to make sure that you see that logo, because it's telling you that chances are pretty good you're going to save 20% or more of your water. The smart controllers are cloud-based, whether they are communicating via Wi-Fi or cell modem or Ethernet. And as such, you can access them from any computer, tablet, or cell phone. One of the things that I think is really cool is while you're on your property, this little guy right here, your smartphone becomes a remote for your sprinkler system. So you can walk around and turn things on and off and make sure they're working. You could even be on vacation and hear there's a monsoon coming, and you could turn your controller off from Reno, Nevada, or wherever you went on vacation. Again, automatic adjustment on a daily basis based on evapotranspiration. You get wiring diagnostics and alerts sent to you via text message or an email alert. Wonderful reporting capability for accountability purposes, so that you can show you're making good use of the water that the city of Glendale provides you. And last but not least, and kind of a new thing, but a big thing, these smart controllers give us the ability to do flow. So the controller will actually learn and monitor and react to flow. So for example, if your lawn sprinklers come on and it learns the flow at 12 gallons a minute, and tonight it waters 12 gallons a minute, tomorrow night it's 12 gallons a minute, everything's fine. The next night, if it waters and it's showing 20 gallons a minute, then the controller is going to know there's a problem and it's going to react, and it's actually going to turn that zone off to prevent all that water from being wasted. Maybe there's a broken head or a broken pipe, and it's going to send you a text message or an email alert to let you know there's a problem with your system. Now, I mentioned in one of my slides early on that I had a special opportunity that I wanted to present to you this evening, and it's going to be concerning two smart controllers. One is this Rachio Gen 3 controller, which is a very popular controller. It's Wi-Fi based. So again, you do your programming with your smartphone. Your smartphone is a remote. You have access to your controller wherever you go. You get the alerts that I talked about. So this is the Rachio Gen 3. And the Hunter HC controller, it's called a Pro HC with HydroWise. So here's what the deal is. Every year, Ewing partners with our friends at Salt River Project for their Water Conservation Expo. As it happens, we're having to do the Water Conservation Expo virtually this year, but it's actually going on right now. So at the Water Conservation Expo, if you register for the expo, which you can do online on Salt River Project's website, and you sit through a video that will give you some information about the controllers, you can then get an amazing opportunity on a controller. So the Hunter controller normally has a retail price of $369. But for the Water Conservation Expo, the manufacturer has discounted the price, Ewing has discounted the price, and then Salt River Project throws a huge subsidy at this particular controller, such that by participating in the virtual expo this year, you can get one of these Hunter controllers for $60 plus tax. The Rachio controller, and the one you see on the screen here, is an indoor controller. So what the deal is at the expo is that you get the controller and an outdoor enclosure, because most of our controllers here in Arizona are installed outdoors. At the expo, where the retail price of this controller would normally be $259, you can get this controller for $60 plus tax as well. So based on what you're seeing there on the retail price and the features and benefits that we covered, this is an amazing opportunity, and I wanted to make sure that I presented that to you with City of Glendale's permission tonight. So if you're interested at all in upgrading your controller to a smart controller, I would certainly encourage you to take advantage of this wonderful opportunity by going to Salt River Project's website and registering for the Water Conservation Expo. And you can do that over the course of the next week or two, but it's literally going on right now. So for more information, and Amine had this at the beginning of the presentation as well, you can certainly visit Ewing Irrigation's website, or I would invite you to visit one of our 17 Phoenix area locations. We have several, although we don't have a store in Glendale proper, we have several in the surrounding communities. So I would invite you to visit there. And I want to thank you for sitting through the presentation this evening. I have dumped a massive amount of information on you in a short amount of time. And I hope that you've learned a lot in a short amount of time. I hope I have not confused you. I hope I have helped you understand some things and the science kind of behind some irrigation. And without any further ado, then I'm going to let Amine maybe moderate any questions that you might have, and I will do the best I can to answer them.
Thank you so much, Doug, for a wonderful presentation. It was very informative, and I liked how you really went through step by step and just showed the opportunity of how we can have more water efficient landscapes. Definitely feel like we can all take control of our irrigation controller now. So we did have a couple questions that came through. And so Evan had a question. So he has an Aerotrol unit, but he only has 2 actual water valves. Should he put in more valves to develop more zones?
Should he or could he? He certainly doesn't need to, but the smallest Irrigation controller is going to be, if it's a rain dial, is 6 stations. So he has multiple opportunities to add more zones, which might give him an opportunity to do more with either hydrozoning, like we talked about, and separating out some of that plant material, or he could certainly add some new landscape and some new irrigation, like if he wanted to have a garden or some pots or something like that. He certainly has opportunity with his controller to expand or maybe improve on his irrigation system.
That's good that he has options. Like you said, the hydrozoning will really be helpful in case, like you said, he wanted to start a garden, or maybe he wants to put some shrubs on a zone and trees on a zone, depending on what he has going in his landscape. And kind of building off of that question, are there any good resources available for Evan to set the Aerotrol controllers? Like maybe like a how-to on like how to set the different zones, depending on the information that we provided in tonight's class?
Right. Depending on how old the controller is, Evan may not have these first couple of resources that I'm going to talk about, but all the controllers, of course, come with instruction manuals. Of course, that may not be around anymore. And most controllers on the inside of the controller door have some sort of a quick startup or quick programming guide. And again, with some older controllers, that's not there anymore. But I would encourage looking at YouTube. There's just a ton of information on YouTube. And so you could go to YouTube and just type in YouTube videos and type in programming Irrigation controller and see what you find. That's a really great resource. And or if that doesn't pan out, again, you could go to your closest Ewing location or any other sprinkler distributor. That's such a popular controller that anybody at any of those irrigation distributors would be a good resource in helping to program that.
Thank you so much, Doug. That was awesome. Yeah, Evan said that zone 2 has plants around, is near with plants around the pool. So yeah, maybe depending on what that material type is, definitely breaking that zone up a little bit more depending on what the watering needs may be.
Could do that.
Awesome. Thank you so much, Evan, for your questions. We have another question that came in from Heather. She said that she staked one of the Christmas decorations into the irrigation line. Oops, how do I know if the line is clear, or how do I clear it? The last two plants where I broke the line barely drip.
Well, Heather, don't feel bad. An irrigation system is underground, it's buried, and unless you're the one that put it in, you don't know where it is. So that happens frequently, and making the actual repair is not usually a problem. But yeah, you may have introduced some debris into the line, and it's going to be very important when you do that kind of damage to a sprinkler line to flush that line out. So typically what you're going to do, if it's if it's a lawn irrigation system, you're going to go to the last sprinkler head, and maybe it's even depending on how the piping runs, you might have to take a couple of what you think are the last heads on the line off. And you don't need to take the whole sprinkler head off, just unscrew the lid and take the lid and the internal off, set that aside. If it's a drip system, a lot of times they have a flush end cap on the end of the black 1/2-inch poly line, and it's just got a little hose cap on it. So you just unscrew that hose cap. But you might, if you don't have that, you're probably going to need to take that last emitter off the line some way. If it's a bubbler system, you're going to have to take the last bubbler off, just unscrew it off the riser, run that valve manually for it's not going to need to be very long, maybe 10-15 seconds. You should be able to flush the debris out and then just put the system back together and you should be fine.
Wonderful answer. Thank you so much for that. We had another question that came in. Elena said, thank you, Doug. She enjoyed this. We have an air controller in our HOA in Sun City, and also 2 other types. I don't recall the names. I run around and turn off the water when it rains. So as you can imagine, the wireless rain sensor sounds great. Is it costly and effective? And also, I don't have to climb ladders to attach to the roof line, correct?
Okay, there's a couple of things in there. Number one, thank you for doing that, because not many people take the time to go around and turn off the controllers when it rains, because not only do you have to turn the controller off when it rains, you then have to make a second trip back and turn it back on. So I appreciate and applaud your effort in doing that. I'd love to have you have a wireless Irrigation rain sensor on those controllers so that you don't have to do that. Is it costly? Let's say that it's less than $100. I don't know the price off the top of my head, but let's say it's less than $100. And is it effective? Yes, absolutely. The way it works is it has little wafer discs inside of it, and you can change the calibration on the device. So you can say, I want it to turn off the sprinklers if we get 1/8 of an inch of rain, or 1/4 of an inch of rain, or 1/2 an inch of rain. Because if you just get a little 1/8 of an inch of rain, that's not a big deal, and maybe your lawn didn't get enough water. So you're probably going to want to set it for a little higher tolerance. But what happens is there's little wafers that swell as they get wet inside that device. And when they swell up, it interrupts the common. The common is a wire that runs to all of your valves. It's normally a white wire. So it runs from the controller to all of your valves. And in order for those valves to turn on from the controller, there's 2 wires that are going to run out there, a hot wire and the common wire. And both those have to be connected for the zone to come on. Well, this rain sensor device interrupts that common and prevents the signal from going out to the valve. So it cannot turn on the valve until those wafers dry back out. And the wafers dry back out, replicating the way the soil would be drying out in a landscape. So I consider to be cost effective, and I consider to be effective.
And then this other part to her question is she doesn't have to climb on any ladders to attach it to the roof line, right?
Well, it needs to be installed in a place where it's exposed to the elements. And you want to install it someplace where it's aesthetically pleasing. So I would suggest that it's normally installed on the gutter. If you have a gutter, it has a bracket that's intended to be installed on a gutter, but people install them on poles, they install them on trees. So it's just wherever on your specific property it makes sense. And no, you wouldn't necessarily have to climb on a ladder to install it if you had an appropriate place. They can be installed on like a cinder block wall, for example. So it just depends on what you have to work with.
Thank you so much, Doug. It was so great to have you tonight. Such a pleasure to hear your expertise and thoughts. I'm going to look to see if we have any last minute questions coming through. Looks like Tish shared a resource on Google called Rain Doctor, and Evan found a great resource on your website that talks about how to program the irrigation controller and shared the link in the chat. Oh, we had such great comments. So again, thank you so much for coming in tonight and just, sharing your experience and just all that knowledge that you have about irrigation controllers. I think it really, really helped me tonight, and as well as our attendees, on understanding how controllers don't have to be so scary.
Well, thank you very much for having me. I enjoyed it very much.
Awesome. And I just want to send a reminder to everyone. Of course, we'll be sending a follow-up email with the PowerPoint, the resources, the recording, and the link to the survey. Remember, if you complete the survey by Monday, you'll be entered to win a free gift card from a local nursery, so don't miss out on that. Our next workshop in our Green Living series is rainwater harvesting, which will happen on Wednesday, March 24th from 5:30 to 7 p.m. So same time, and that's exactly 2 weeks from tonight. And I hope everyone has a great night and takes care. And thank you so much again for joining us tonight.